Hello. Can you hear me? Do you see the desktop and can you hear me? Does everything seem okay now?
Yeah, we can hear you and see you.
Okay. Let me I have to bring up a couple windows. Okay. So, um, let me refresh this page. There. Okay. Here's the entry for today. Okay. So, I moved the programming assignment notice to today. It still isn't quite ready yet. I've been working on it, and it still shows as not found. It'll be up there, I hope, this afternoon or this evening. I've been working on it. Okay, so the program assignment is going to come. It'll be there soon. Okay, so that's the first thing to let you know about. And then today we're going to start reading about. I'm sorry, we're going to start talking about this chapter 4 reading, and we're going to be talking about this idea of methods. And then here's some more. Here's several sections more about methods and something called objects. We're going to be talking about methods and objects. So this is the reading for on when we meet on Thursday. Okay, and remember this other book. These readings coming from alternating between two different books. This other book, its readings have a lot more problems that you can work on in it. When you start working here, you see little problems. I really encourage you to do these problems and try them. I think they give you they help you think about what you're reading as you're going along. So this book has got lots of little problems that you can just check, answer the question as you're going along. So when you do the reading for this from this other book, when you do these readings, please make sure that you do the built-in problems. They're pretty good. And if anything's funny, if you don't understand anything and you're not sure what how to answer a question, you can always send me an email. If anything in those seems is something that you don't understand, please send an email and ask or come to the office hours. I remember I have office hours this afternoon. On Tuesday, Thursday, there's office hours in the afternoon. So if you have questions about anything like that, please come. Okay, so let's go and start talking about this chapter 4. We want to talk about something called methods. There's this idea of what's a method. We want to talk about methods. Okay, so here they give you an example of a method. In a minute, we'll switch to actually be able to run it. Here's what a method is. Lets you take lines of code, like this is just one line of code, and give a name to a group of lines of code. Okay, a method. So this thing here is a method. And actually, when you did your first homework assignment, you also wrote a method. You wrote a method called main. Okay, main. If there's a lot of extra stuff going on here, like we're not going to say what the word public, static, and void mean for a while, but main is the name for that method. And here the name is new line. New line is a name for, well, here it's a name for just one line of code. Here, main is a name for 3 lines of code. Okay. Now, if I go down here, here's 3 methods. The main one called 3 line and one called new line. This one's a name for one line of code, but this one's a name for 3 lines of code. Okay. And then whenever you have something that's gotten given a name, you could use the name. Okay. So down here, main uses the name 3 line. What that does is essentially say, take this line, take these 3 lines of code and substitute them in here. That's what the effect has. Or another way to think about it is when you get to this, what you do is you say 3 lines is a name for something. Go up to where the name is and start executing that code. Then when you get to here, you say, oh, I'm done doing 3 lines. So you go back down to here and you do the next thing. Okay. So when Java starts your main method will print this here. Java will see that, say, oh, that's a name for something. It'll go up to where there's the name and it'll do that, that, and that. But each one of these is a name for something. Now, notice that you put this pair of parentheses at the end of the name, that's the thing that says call this method. This is the name for a method. When you put a pair of empty parentheses at the end, you're saying call that method. Now, so here, the empty pair of parentheses said call that method. So let's actually watch this run. Okay, if we click on run, okay, we get the output. Okay, now all that happened super fast. I mean, essentially what happened was when this thing ran, when we click run, we're running our main method. Okay. Oh, actually, let me check something. See how the people who wrote this example kind of goofed it up. See these blanks here? They're really coming from this thing here, but this thing's hard. It's hard to realize that these blanks come from here. Let me do something. Let me put something in there. I'm going to put a dot in there. Okay, then I'm going to run this again. And what, no, I'm sorry, I put it in the wrong place. This print line, I'm going to make it print a dot. Okay. So now when this thing executes, you actually see a dot. So now if I click run, okay, here's what it did. My main method, when I clicked run, I'm running the main method. So that's telling the main method, do your work, execute all the code that's inside main. So it prints out first line. That was out here. Then it said, well, execute 3-line, or we say call 3-line. 3-line is a name for this method. You put the empty pair of parentheses at the end that says call 3-line. So you jump up to here and you start executing these 3 lines of code. But this calls new line. So this jumps up to here and executes just 1 line of code. So it prints out a dot. That's this purchase dot. Then you go back here and then you call new line again. That prints another dot. Then that returns to line 9, and then you go to line 10. Line 10 calls new line again, prints another dot. Okay. Then when line 10 is done, you'd finish this. So you finish line 15 where you start, where that's where you called 3-line. So this thing ended up putting the 3 dots there, and then you do this line here. Now, in this book where this system here, you actually don't see all that happen. You click run and you see the result of it all happening, but you don't actually see it happen. But if we take this code and we move it into this other website, the Java Visualizer. So I'm going to open up the other website that we sometimes use, the Java Visualizer. Okay. I'll delete the code that's in there now, and I'll put in the code I copied from the book. The Java Visualizer does a better job of letting me watch all these things happen. So if I go down here and I click Visualize Execution, now I'm going to watch step by step what the words I said what were happening here. We could actually see them happen now. We'll watch them happen step by step. So I go over here and I'm going to start running my program. So it starts at line 14. When you run your program, you start at main. Well, main says do line 14. So I click forward and line 14 happened and I got this output. Now I'm about to do line 15. Line 15 is a call to the thing called 3-line. Okay, so that means it's telling Java jump up here and start doing this. So I click forward, and from line 15, I go to line 8. See, I jumped from 15 to 8. Okay, so now I'm in 3-line. And if you look over here, I've got another, over here is something that tells me what just happened. I was in main at line 15. See the little gray box that says I was at line 15 in main, and I jumped to line 8 in 3-line. Okay. Okay. Now I'm about to do this, but this is another method call. This says call method new line. So line 8 is going to jump me up to line 4. Okay. See, now over here, I'm in new line at line 4. I came from 3 line 8, and I know that that one came from main, line 15. So I went from this call to, I called into this method, then this one called into that one. Now this is actually another method. See the parentheses? This is a method that that the Java people wrote for us. Print line is a method that they wrote, not that we wrote. We wrote this main. There's what it looks like. We wrote this guy. There's what it looks like. We wrote new line. This is what it looks like. Java language wrote print line, and what it does is it makes things print over down here. So now we're going to call print line. Okay, so we click forward. Okay, line 4 happened. There's the dot that it printed. We're done with new line. Okay, we're at new line 5. We came from line 8 of 3 line. So now that we're done with new line, we're going to go back. But we're going to go back to line 9 because we're done with line 8. So see, now I'm going to go to line 9. Notice how I went from, I finished, well, they show you finishing a method by showing you is at the closing brace. See, if I go back, they show you that you're about to leave this method. You're going to return to where you came from. See, we're going to return to line 8. So we're going to return from this method. And they show that as being at the brace. That means you're done. So you're going to return to where you came from. Okay, we're going to return to, so we return down here to line 8, except 8's really done. So we actually return to line 9. But line 9 sends us back up to new line. Okay, now see, we're at 3 line 9. We click forward, and we're now at new line 4 again. We're back to that line, but now we came from here. So we came from line 9, we called new line, and we're at line 4. Okay, we're now about to call print line. Okay, and we're going to see the parentheses say that we're calling something called print line, and that's written by the Java people, so we don't really care what it looks like. We just use it. They wrote it for us, and we use it, and it does something useful. It prints things out. So I click forward. Okay, that print line happened. That's that second dot down here. I'm done with this method, so I'm at its closing brace, and I'm about to return to where I came from. I'm going to return to line 9, except line 9 is actually done, so I'm going to return to line 10. So I'm at line 10. Line 10 sends me back up here. Okay, line 10 sends me, see, now I'm at new line 4 again, but this time I came from line 10 of 3 line. So line 10 of 3 line sent me to new line 4, the first line of new line. Do the print line. There's the third dot down here. We got our third dot. Okay, we're at the end of new line. Okay, so now we're going to, now the words I'm using are actually important. So what we're doing here is we're returning to the method that called new line. 3 line 10 called new line, and new line's going to return to where it was called from. Okay, and when we talk about this stuff, and when when you're reading the book and when you ask questions, we have to start getting used to this technical language. These are special words in the Java language, talking about calling and returning. Methods call each other. This method calls that method. When this method calls that method, you go to that method. Then when that method's done, you return to where it was called from. So now I'm going to do the return. I'm going to return to line 10, except line 10 is done. So I'm really going to return to line 11. Okay. Now, at line 11, that means I'm done with new line. I'm at the a 3 line. I'm at the end of 3 line. I'm at line 11 of 3 line, which is the end of it. So it's now going to return to main's line 15. So now I'm going to return to line 15 of main, which called 3 line. Except line 15 is done, so I'm really going to return actually to line 16 this time. So line 15 is done, so I'm going to return to line 16. Okay, now line 16 makes one more method call. It calls print line. Okay, so that did line 16. Now that jumped to print line, did all the code in print line real fast, but since we didn't write print line, the visualizer doesn't show us that. But the Java jumped to the code in print line. Okay, it did the work of print line, which is to print this stuff out here. Then when it was done, it print line returned to line 17. Now we're about to return from main, which is actually where our program's ending. That means our program ended. Notice that the buttons here are gone. When main returns, your program is done. Okay, the returning of main is the ending of your program. Beginning of main is the beginning of your program. So your program starts here and your program ends here. But while your program is doing main, it can take all these detours into other methods. Okay. Okay. Now let me take this. I'm going to open another window of Java Visualizer. And I'm going to make a change to this program. So I want to keep this so we can go back. If there's any question, we can go back to it. So I'm going to keep this and I'm going to copy it and I'm going to paste it into Java Visualizer again and make some changes to it. So I'll delete what's in there, add our code. And what I'm going to do is I'm going to define another method. Okay. So let's see. You write a method by typing, for now you type public static void. We don't really know what those mean yet, and we're not really saying what they mean. Okay. And then I'm going to type something called 6 line. Okay. And what 6 line is going to do is it's going to call 3 line one time, and it's called 3 line a second time. Now 3 line will print out 3 lines, and you call 3 line again, it'll print out 3 more lines. So this prints out 6 lines. Let me try to get this stuff to line up. Okay. For some reason, it's not lining things up properly. Okay. All right. So now I've got a new method. Now it wasn't very hard to write a method. I type public static void. That will eventually we'll learn what that means. I give it a name, and then these parentheses here, we'll see what they're really doing, but for now they just stay empty, but they eventually say that this is the name of a method. Then I have an opening brace. Oh, I have two. That's what was a mistake I made. I made too many opening braces. I have the opening brace, and the opening and closing brace lump together lines of code. So what a method is doing is it's lumping together lines of code that you can then use over and over again. Okay. It lumps together lines of code and it gives them a name. So the method does two things: lumps code into a unit and then gives the unit a name so that you could call the unit and make use of it. You can treat these 3 lines now as one unit. 3 line, this gives me 3 lines of dots. Okay. So now if I call it twice, I get 6 lines of dots. Now, okay, and down here I can call my 6 line. Okay. So I can call my 6 line instead of calling their 3 line, I can call my 6 line. If I now visualize it, okay, and if I go to the end, I can look at my output. See, my output now has 1, 2, 3, 4, 5, 6. okay, has 6 dots in between this first, and actually they called it second line, and it's not really clear why they called it second line. It should have been last line. It would make more sense if this said, because even in this example here, this was not the second line of output because there's 3 lines in between here. So this was actually the fifth line of output. So it'd make more sense to call this the last line of output. Okay, it would just make more sense to call that one last line. Okay, so now I have if I now in the Java visualizer, if I click last, I see what the final result of my program is. That's kind of nice. You can just jump, you can go forward to the very end, which is exactly what it's like when you run over here. When you run this, you just see the end result. When you run this, you go straight to the end result and you see what the result of all this code is. You don't get to watch it go step by step. Okay, in this system, that you can run a program in their book, but you can't watch it execute line by line. Okay, so over here in the Java visualizer, when we want to run the program and just see what the output is, what we do is we go to we can either go, this goes back to the beginning and this goes to the very end. So I can go beginning, end. Okay, if I'm at the beginning, I could either step through the code or I can go back to the beginning again. Okay, so this one lets us either go straight to the end, like this one does that automatically. This one just goes straight to the end and you see the final result. The visualizer lets us do that by clicking last. Okay, I see the output. I've got my 6 lines here. If I want to watch it, okay, the way I watch it now, make that bigger so I can see a little bit more. Okay, I, I'm I'm at line 19 of main. That's where I start. That's my first line of my program because my program starts at main. When I run my program, Java always starts in the thing you called main. The thing you call main is you have to have a program, you have to have a method called main. If you don't have like for example, let me go back here. Let me change the name of main to man. Okay. If I visualize execution, I get an error message because right now there's nothing called main, so your program doesn't have a starting point. The name main is defined by the Java language. You don't have any choice about it. You have to write a method called main to get your program started. If you don't have a main method, there's nothing Java doesn't know where to start your program. It doesn't know, should it start at this method, should it start with this method, should it start with this method, or should it start with the thing called man. So there has to be a method called main, so because that's where every program starts in the main method. The main, it was called main because that's in a sense the most important method, the main method. Okay. So there must be a method called main to get your program started. Okay. So you don't have a choice about this name. You use that name. Okay. And you can put anything you want in main, and you can have other methods that your main method calls. Okay. Now I click here on visualize. Okay. So I'm at my first line of my main, and I'm going to go to, well, I'm going to call the built-in method called print line. Okay. I just called the built-in method called print line, which printed out this. And now I'm about to call my method called 6line. So 6line is up here. It starts at line 14. So see, now I'm at line 14 and 6line. From line 20 of main, I called line 14 of 6line. So I can see here, I came from line 20, went up to line 14. Then 6line calls 3line. So now I'm at 3line in line 8, which I got there by calling it from line 14 of 6line, and I got there by calling it from line 20 of main. Okay. So I'm now up here, but 3line calls new line. Okay, right. Now notice how I got the stack of things over here. I'm at line 4 in new line. How did I get there? Well, line 8 of 3 line called new line. How did I get there? Well, line 14 of 6 line called 3 line. How did I get there? Line 20 of main called 6 line. Okay, so I'm up here at line 4, but I got there from this calling this, which called this, which called this. And now I'm going to call print line, which prints out one dot. Okay. Now I'm going to go back to line 8. Okay. Oh, but 8 was done, so I actually went back to 9. See, I returned. See, there's the thing that we think of as the return. I return. Excuse me. I returned I went from line 5. While I was going back to line 8, the line 8 was done, so I just jumped down to line 9. So Java knew that line 8 was done. So even though it says here that it came from line 8 is done. So when it returns to the next line, which is line 9. Line 9 sends me right back up here. Now notice that there's only, now I'm in 3 line, I came from 6 line, and I came from main. So there's 3 method calls that are in progress right now. So main is being done. In the process of doing main, we call 6 line. In the process of doing 6 line, we call 3 line. So we're in the middle of doing 3 methods. Okay. 3 lines going to send us back up to new line. Okay. Now I'm back at line 4 in new line, but I came from line 9 of 3 line. Okay. So if I click forward, I get another dot out. And notice that what we're doing here is something that is called if we go back to the book, it's called the flow of execution. We're watching the flow. Okay, execution means do your code. Do the things that your code says to do. So you execute 3 line by jumping up here. You execute new line by jumping up here. You execute print line by printing out what's inside here. That's executing a line of code. The flow of execution is watching these things jump back and forth and keeping track of them. Like over here, this is keeping track of the flow of execution. See, this thing, the flow was, I started at line 20 jumped to line 14, line 14 jumped me to line 10, then line 10 jumped me to line 4. That's the flow of execution. You know, if I look at the page over here, I can kind of see that myself. If I read this carefully, I see, well, if I'm at line 20, it says to jump up here to 6 line. Well, it'll take you to line 14. See, 20 will take you to line 14. But line 14 calls 3 lines, so line 14 will take you up to line 8. So line 14 will take you to 3 line. Well, it'll first take you to line 8 of 3 line, but then eventually you'll finish that and you'll get to line 10. See, we're actually by now we're at line 10 of 3 line. And then that took us to eventually, after you've done that part of 3 line and that part of 3 line, you get to line 10 of 3 line. Then that takes you up here to line 4 of new line. Okay. So you can see the flow of execution over here, but you have to picture it in your own mind when you look at the code. The nice thing about the visualizer is that if I just, like, for example, if I go back to the beginning, if I watch this yellow line, it's jumping all over the place. That's the flow of execution. So I'm just very quickly, see, now I'm at the very end. See, notice that when the yellow line got to there, I'm at the end of my program. Okay. And if I go back to the beginning, I can do, yeah, the flow of execution is this idea, okay? The flow of execution is this idea that the computer is executing your code. And what it's really doing is it's stepping through your code. We think of it as flowing through your code. So we use this phrase, the flow of execution. The computer is flowing through your code, jumping around, executing line after line after line. So it's executing line after line after line. In the Java visualizer, the yellow bar shows you what you are executing. and the gray bar shows you what you just executed, okay? The yellow bar is what you're about to execute, and the gray bar is what you just executed, okay? Like right now, I'm about to return from 3-line. What I just did was return from new line. New line returned from that last call to there. So I returned from new line. I'm about to return from 3-line. I click forward, and now I'm about to call 3-line after I returned from 3-line. See, this return was from that call to 3-line, and now I'm about to do another call to 3-line. So now this yellow bar is going to go right back up into 3-line. Okay, the yellow bar went back up to 3-line, and and then I can keep watching the flow of execution. Okay. Oh, one thing about the Java visualizer is kind of neat. You can go backwards and forwards. If you notice there's a little slider here, you can actually just grab the slider and slide you and watch your program kind of like a movie go back and forth. And they keep track of how many steps your program has. Like this program has a total of 46 steps. If you count how many lines this program actually, notice the program has 21 lines of code, but it does 46 steps of execution because some of the code is done repeatedly. We call 3-line twice. So line 8 gets done 2 times. We call 3-line here and go up to line 8, so it gets done once. Then when we call 3-line again, we go up to line 8 again. So line 8 gets done 2 times. Line 4 gets done a bunch of times. We end up with, I'm going to see how many lines of output do we actually end up having. We have 6 lines of output altogether, okay? So that means that print line is called, this thing is called 6 times because there's going to be 6 dots altogether on the output. So line 4 is itself called 6 times. So the program has that many lines of code, 21 lines, but my program, when it runs, it does 46 steps. And I can, you can, if you want, I don't find this bar all that useful. It's kind of cute. You can watch your program run real fast. Okay. What's more important is that you can just step through your code. This is what you should do. You should practice these problems and step through, and you should right now what you should be doing when you think, if you look at this when you're on your own, is you should predict what the forward button is going to do. Like right now, the forward button is going to print first line. Okay. Right now, the forward button, well, I'm at 6th line. So the forward button is going to take me from 20 to, well, first line of 6th line is 14. So the forward button is going to take me to 14. So you should predict what each forward button is going to do. Okay, that way you understand the flow of execution. You can predict what forward will do. Okay, like right now, I'm up here. Forward's going to send me to line 4. Okay, now forward's going to do print line. It's going to call print line, but print line is going to make a dot appear down here. There's the dot. Okay, now and this one's a little bit tricky. I'm at line 5. That means I'm at the end of new line. So forward's going to return, but I have to know where to return from. I can't tell that from over here, but I can tell it from over here. Where does new line 5 return to? 3-line 8. See, that's what this right-hand side actually helps you see. You can't tell everything from over here. When you're at a return of a method, this picture here doesn't tell you what it's going to return to, because new line was called from there, and from there. If you just show me this picture that I'm at line 5, I'm returning from new line, but I don't know if I'm returning to this one, or this one. But over here is more information. I'm at line 5 a new line, and now I see, oh, I'm going back to line 8. So clicking forward is going to take me, well, line 8 is done, so it's going to take me to line 9. So forward is going to take me to line 9. Okay, so I can predict. Okay, but I need both sides of this picture here. I need this code here, and I need this what we call the frames. I need this picture, I need that picture over here to help me know exactly what's going on. Between the two sides of this picture, I can always predict what forward's going to do. Okay, so that's one of the things you should be thinking about when you practice these, when you try these, is you should predict what the forward button will do. Okay, now let's add another feature to this code. Okay, I'm gonna copy this. So if we want to, I want to make a copy of it and then and make a change to it. I'm gonna keep the previous version just because if we want to go back to it. Okay. Now what I'm going to do is see how print line has something between the parentheses. We call that an argument. Okay. What that's saying is you're telling print line to do something for you, and you're saying do it with this dot. In other words, print this dot. So when you call this method, you're giving the method a little bit of information, saying call the method with this extra piece of information. Okay. What I want to do is I'm going to add an argument to new line. I'm going to say, okay, I'm going to give new line an argument. Okay, so the way you give a method an argument is you say what kind of argument it is. It's going to be a string argument, and I'm going to call it arg. Okay, so I have a string argument. Okay, and then so this thing now new line takes in a piece of information. And what it's going to do is it's going to take that piece of information and put it after the dot. Okay. So new line is going to take in a little piece of information and it's going to put it after the dot. Okay. And what I'm going to do is the piece of information I'm going to put here is that when I call I'm going to put the string 1 here. I'm going to put the string 2 here. I'm going to put the string 3 here. Okay. Now what that's going to do is going to print dot 1 when this new line is going to actually print dot 1, this new line is going to print dot 2, and this new line is going to print dot 3. What's going to happen is that when I call new line, I'm going to give it this argument. This argument will go into there. So then arg will actually, it's a variable, and the value it holds will be the string 1. But when I call new line here, I will say we pass that argument to that variable, and then that variable represents 2. So I'll print out dot 2. Now let's watch this happen. Okay. So far nothing's going to be different. I'm going to print out first line. Then I'm going to call 6th line. 6th line is going to call 3 line. Okay. Oh, now things start changing a little bit. Now, 3 line is going to call new line, but it's going to pass an argument to new line. So here's what it looks like when I click forward. Line 8 of 3 line called line 4 of new line and passed it the argument 1. So see now up here, this guy holds the value 1. Okay? So new 1 was passed up into here. So this value, this string, got the name arg. Arg is now a name for the string quote 1. Okay. When this one prints, it's going to print, see, dot 1. Okay. So it printed a dot followed by its argument. And if I click forward, I return. Now I'm going to call new line again with a different argument. Okay, I'm going to call it with a different argument. So now I'm going to jump back up into here. So I'm going to jump from line 9 to line 4. So you always want to predict what the new forward button does. The forward button now is going to jump from line 9 to line 4, but arg will now have the value quote to quote. Okay, so I went from line 9 to line 4, but arg has the value quote 2. Now print line will print dot plus. This is, remember, this plus now is not addition. It's the thing it has the funny name concatenation. It takes the string dot and the string, in this case, 2, and builds the string dot 2, and it prints dot 2, okay? And then it returns, and it returned to, when print line was done, it returned from here, but that was done, so it actually returned to line 10. And now it's about to call new line again, okay? Now it's got the arg3. We passed the value 3 into that variable, okay? So then it prints 3, okay? Now when we return, we're done with 3-line. 3-line returns back to 6-line, but line 15, and line 15 makes us do 3-line again. Now we're back up here to line 8, which calls new line with that argument again. So now we're going to get another dot 1 on our output. Okay. There's another dot 1. There's a dot 2. See, the arg is 2 now because we're at line 5 from 3-line 9. 3-line 9 had the argument 2. See, so the arg is 2 because we came from line 9, which called new line with argument 2. Okay. New line's returning. Now we're back in 3-line. We're in 3-line, line 10, and we're going to call new line again, but with another argument. Okay. Okay. Now we call new line with the argument 3. So we're going to print out this 3 here. Okay. Now 3-line is done. We return to 6-line, but 6-line is done. We return to main. Main does one last thing, prints last line, and the program's done. Okay. All right. So methods can take extra information that says when you're executing the method, use this extra piece of information. These extra pieces of information are called arguments. Okay. Now, this notation comes from algebra. Okay, let me show you what I mean by that. Let me type something into. I'm going to create a little. I'm going to create a little file. I just call it notes. Okay. In algebra, you can define what are called functions. A function would be something like f of x equals, say, 3 times x plus 4, mx plus b, a linear function, okay? This notation with the parentheses here is the same notation we're using with our methods. See, that's the name of the method, and that's the input to the method. Just like over here, that's the name of the function, and that's what you give to the function as input. Okay. Now, down here, what's f of 2? What's that mean? Okay, let me, what if somebody now writes f of 2, what does f of 2 mean to you?
You're replacing x with 2.
So then what do you get?
10.
10, yeah. Because what you do is you take the 2, you go up here, and you plug the 2 into here, which then takes that and goes, oh, the 2 goes in here. So that's 2. 2 times 3 is 6, plus 4 is 10. So this guy is 10. That's exactly what happened over here. We see, compare that. See, that's where programming languages got these ideas. They're literally taking these ideas from algebra. Here's the name of the function, and I'm giving it that argument. So then I use that argument in place of that variable. Just like here, I use that argument in place of that variable. I substitute 2 in for x. And then I use 2 wherever there's an x over here. Okay. On your hand, like over here, what's f of 3? Well, you take 3. Now, see, this is a, using Java terminology, this is a function call. This is another function call. Over here, over here, Java uses the word method, not function. In fact, the languages like C and C++ and JavaScript, they call these things functions. Okay, in the world of C++ programming and JavaScript programming, these things are called functions. But for some reason, the people in the Java world called them methods. Okay, so a method is a way of doing things. If somebody says, I have a method, so he means I have a way of doing things. Well, this method is this way of doing things. That's the way of doing it. So this is a method. It's a way of doing something. This is a method. It's a way of doing something. So I don't really think it's a great name, yeah, but they call them methods. Now, function is just a word that comes out of algebra. People call these things functions. I'm not even sure what the history of the word function is, but function means it's a name for a formula. See, what a function is, it's a name for a formula. So you can use this as a shorthand for that formula. Okay, and then this tells you what value to plug into the variable of the formula. So this thing is called a function definition because it tells you what the function means. So this is a method definition. So if you go back over here to the beginning, that's a method definition. Okay, so that's a method definition. So is that one. So is that one. So is that one. Those are all method definitions. Okay, this thing is a method call. Okay, and so is that one. So is that one. But so is that, and so is that, and so is that line, that line. These are all method calls. Everything in our program is a method call. Every line of code in this program is calling some method. Okay, and this is a method call because it's calling print line. Okay, now over here, now you've maybe never seen it in your algebra class, but I could find a function with 2 variables. And I could say this is 3 times x plus 2 times y. What would g of 1, 2 be? This is a method call with 2 arguments. What would g of 1, 2 mean? What do you do with the 1?
The 1 goes in the x and the 2 goes in the y.
Yeah, so the 1 goes in the x, and that gives me 3 times 1 is 3. The 2 goes into the y, gives me 2 times 2 is 4. So 4 plus 3 is 7. Okay, so this thing gives me 7. So this is a method call with arguments 1 and 2, and it means put 2 into the x, 1 into the x, 2 into the y, and then do this, which is exactly what Java programming is actually based on these ideas from mathematics. I mean, that's programming languages took these ideas and said, that's how we should write programs. We should write programs as essentially functions, and you call a function with arguments, and that represents doing something. So this represents computing 10, or I'm sorry, this represents computing 7. This represented computing 13. Okay, 3 times 3 is 9, plus 4 is 13. So this represents computing 13. Okay. A method call represents doing some calculation. Okay. In the Java language, when we give a name to a method, after the name we put the arguments to the method. But in Java, you have to tell me what kind of argument it is. And like in this case, now you don't do that in math. There is all these arguments are numbers in math. Okay, this argument is assumed to be some number. This is assumed to be some number. If I did this in Java, Java would say, I don't know what arg is. Is it an int? Remember, we've seen several different kinds of variables. We have integer variables and decimal variables and string variables. Okay, because a variable can hold a string, or it can hold an integer number, or it can hold a decimal number with a decimal place. Java needs to be told what kind of value you want that to hold. In our case, it was string. Okay. Now, we could give this, let's give this a second argument. Let me just, for the heck of it, give it a second argument. That's an int x. Okay. Now, what the, and over here, I'm going to put plus, quote, x equal, close quote, plus x. So I'm going to print out dot arg space x equals space, then the value of x. So I'm going to take in two arguments. So over here, now I need to call it with two arguments. So I'll make this say 42, make this one say 32, and make this one, give this one, the second argument will be 22. Okay. Okay. Now I'm doing something like G here. I have a method with two arguments. Okay. So the two arguments are a string and a number. Not really doing much with them. I'm just printing them out. So I'm printing out the number. This is actually a string that just happens to be a number. So I'm printing the string and I'm printing out the number, but I'm saying it's x is that. Okay. So I'm not doing anything interesting yet with these, but what we're trying to understand here is like the flow of control and the idea how these methods are a lot like they're very much they programming languages got all these ideas from mathematics, from algebra, and the idea of functions in algebra. It really is the motivation for how we do things over here. Okay, so let me go now. Let's watch this one run with this two arguments to this method here. Okay, so I'm going to go ahead and visualize this. Okay, now if I go to the end, here's what it's going to look like. You know, dot 1 x equals 42, dot 2 x equals 32, dot 2 x equals 22. Yeah. See x, this was one of the arguments and this was the other argument. Okay, but let's watch it. Let's go back to the beginning and let's just step through it and watch it build that up. Okay, so nothing's changed yet. Print out first line, call 6 line. 6 line calls 3 line. Okay, now things become a little bit different. In 3 line, we call new line with 2 arguments. So forward's going to take us from line 8 to line 4, but with 2 arguments. Okay, so line 8 called new line, which took us to line 4, but it gave us 2 arguments. Arg is quote 1 and x is 42. Very much like over here. When I call G, I'm saying call G with x is 1 and y is 2. So then you go over here and do that. You go from the you go from the method call to the method definition to see what to do. What does G of 1, 2 mean? Well, I go from the call to the definition to see what G of 1, 2 means. Okay, so same here. I go from the call to the definition to see what to do. And when I go from the call to the definition, the Java visualizer keeps track of what I passed to the variables in the definition. Okay, so I called new line with these two arguments, and this thing keeps track of them. Okay, so now then I call print line with a string that looks like dot arg plus x equal x. So that's dot 1 x equals 42. Okay, so there's that output. Dot 1 x equals 42. Okay, then I go, well, now I'm going to return. I'm at line 5, which is the very end of new line. So I'm at the end of new line. So I'm about to return to line 8 of 3 line, except line 8's done. So I actually go back to line 9. Call new line again with new arguments. Okay, so that's like down here, I could do another call, G of 3, 4. Okay, that's another method call, okay, with 2 arguments. Okay, but it's going to give me a different result. G of 3, 4 is going to give me a different result than G of 1, 2. So same things here. This is going to do something different than this one did because it's got different arguments. Okay, so that's going to end up printing out. Okay, now notice that, okay, when I call this method, I'm going to jump from line 9 to line 4 again. I'm going to go back up to 4, but with different arguments. Now I'm going to go up to 4 with arguments 2 and 32. See, I came from line 9. See, I'm at line 4. I came from line 9. If I go back down here, I see line 9 has arguments 2 and 32. That's what I have here, 2 and 32. So line 4 got those values from line 9. Those values came from line 9. See, this thing's keeping track of a lot of stuff. There's between the two sides, you see a lot going on. Now, over here, they call this, well, we're talking about parameters and arguments here. And we've done multiple parameters. This is the idea that you can have two. See, we went from one parameter to multiple parameters. See this section on stack diagrams. That's these, see the stack. There's a stack of, they're called frames. This is called the stack diagram. The right-hand side of these Java visualizers is what the textbook calls a stack diagram. And see, this is a picture of like what you see on the right-hand side of the visualizer. See, this is a stack. Now here they show the stack going down. The Java visualizer shows the stack going up. Main called 6 line, which called 3 line, which called new line. The stack went up this way. They show the stack is going down this way. You start in main, and in this picture, main called prime time. Main had 2 parameters, hour and minutes, and then prime time had 2 parameters, hour and minutes. Okay, okay. So this is what they call a stack diagram. They show it going down this way. Usually people think, I don't know why they did it that way. It's almost always thought of as going up this way. Time goes up here. Main called 6 line, which called 3 line, which called new line. In their picture here, main called print time. So here time went down, but that's usually not the way people think of these pictures. Almost, yeah. Stack diagrams are one of the key ideas in programming. Learning about programming, you have to learn about how to read a stack diagram, how to understand a stack diagram. They're usually thought of as growing up. Okay, so the thing that's at the top of the stack is the method that you're in. Okay, so the top of the stack, which gets turned light blue here. See, the top of the stack is light blue. That's the method that you're in. So the yellow bar will always be in the method that's at the top of the stack. And then you came from what's below it. Then you got into there by what's below it. And so line 4 came from line 9, which came from line 14, which came from line 20. New line was called by 3 line. 3 line was called by 6 line. 6 line was called by main. Okay. So this picture is showing you the stack diagram, and it's showing you what the argument to each no, 3 line and 6 line don't have arguments. Okay, so 6 line and 3 line don't have arguments, so there's no argument shown here. New line has arguments, so the stack diagram shows us the arguments. Okay, all right, so then you just keep following your nose through this picture just by following stepping through the code. Okay. Now, at this point, I've done one call to 3 line. One call to 3 line gave me those 3 lines. Now I'm about to do the other call to 3 line, which is going to do everything again. It's going to keep, there's nothing changing here. So when I call 3 line a second time, it just does the exact same thing. Notice that's why you need arguments. See, if there's no arguments, then this guy has to do the exact same thing every time you call it. When there's no arguments, every time you call a method, it'll do the exact same thing. See, this guy has no arguments. Oops. This guy has no arguments. So every time you call 6 line, it's going to do the exact same thing. Print line has an argument. So every time you call print line, it does something depending on, it prints what that argument is. The argument's where you tell a method, do this thing for me, and here's something that I want you to do it with. I want you to do something, it prints something out, and then here it's saying, do it with this. Okay? Here we're saying, print one line and do it with this. So this will be this will be part of the output, and this will be part of the output. So print one line with these parameters. Okay. If you don't have parameters, then the method will always do the same thing. And so this 3 line will just give us another 3 lines of output. So you can go real fast through the lines of code. Okay. These 3 lines were from that call to 3 line, and these 3 lines were from this other call to 3 line. These 6 lines were from that call there. If I say, like if I say 3 line here, I'll end up with 9 lines of output. Okay. This will give me 6 lines of output by calling 3 line 2 times, but then I call 3 line again, that'll give me 3 more lines of output. So if I visualize this, if I go to the end, I'll see that I can count the output. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 lines of output because I called 6 line, which gives me 6 lines, and 3 lines gives me 3 lines. Notice that the name of one of the goals is the name of a method should give you a hint of what it's doing. That's different than math. See, math uses names like F and G and H. Okay, in math, you tend to name functions with a single letter. Okay, that's just a tradition in math. You name a function with a single letter, and your variables are other letters. Okay, so functions tend to be function names tend to be F, G, and H, and variable names tend to be things like X, Y, and Z. Okay, so I could do Z plus 4. Okay. Oh, what if I did this? What's H now? What if you wrote something like that in your math homework, or if you saw that? Yeah. What should you think about this thing here?
Wouldn't that just become 2Z?
Pardon me?
wouldn't the answer just be 2z?
Why?
Because it'd just be z plus z.
But it doesn't say that. It says z plus x.
But then it's saying hz though, so wouldn't you replace the x with the z?
Why? You know what? So you have to say, you know, like, what rule of algebra would say you replace the x with a z? So let me give you an example. Suppose I have f of x equals mx plus b. What do you do with f of 2? Do you put the 2 into m and b?
No, you just put it into x.
Yeah, you just put in. So here, the z goes into there. Whatever z. So like here, you would have h of 3. The 3 goes into there. Okay. What about this x? And what about this guy here and this guy here? What's your, you remember, what think about algebra class, or, you know, what do you, how do you read those things?
They're undefined variables.
Yeah, or they're right now they're undefined. So what would I usually do? Like, how do I make sense of this? Because you see this all the time in your algebra class, mx plus b. They're right now they're undefined. So how do you make sense of them?
You'd use other equations
Yes,
and other like things to find them, and then you'd plug them in.
right. So I would say, well, m is going to be 3. I want the slope to be 3, and I want the y-intercept to be 5. Okay. See, I need some other thing that says, oh, m is 3, b is 5. Now the line is mx plus b. But m is, now, where does x get its value from?
From F,
From the
the
function call, right? See, x is going to, see, like here, x gets 2. Here, x gets 10. Here, f gets -4. See? Where does x get its value from? From the function call. Where does m get its value from? Where does m get its value from?
from the outside,
From the
the m
outside.
equals 3. Yeah.
Yeah, from that equation, m equals 3. Now, suppose down here I said, m equals 14.
Then you wouldn't have F. Is that what you're saying? Like you would use M instead of F and then have to find F? Or no?
Yeah, okay, so what? Yeah, so now how would
Okay.
you read this? M is 3, b is 5, f is essentially now 3x plus 5. So now you plug 2 into there, and you get 3 times 2 plus 5. You plug 10 into there, and you get 3 times 10 plus 5. Now, what would this do? It says, oh, update m. So what is that? What do I mean by update m?
When you do the next F, would you make M 14 then
Yes.
instead of 3?
Yeah, you replace
Okay.
the 3 with 14. Okay. You know, normally this would be in a math book where they would be saying, well, you know, there would be sentences that say things like, well, suppose we have m equals 3, and then this is our formula for f. And then they might say, okay, now let's change m to 14. So now f is the equation 14x plus 5. Okay. So this variable is the parameter of the function. And what we usually call these are constants. They come from somewhere else. These parts of the function come from somewhere else. Java doesn't let us do this. Okay, if I go up here, I can't do something like the following. I can't do something like this. Plus y equal plus y. Okay, now I've got a y inside of this method. That's like having this m inside of this function. M got its value from this formula. there's no way for me to give this y a value other than to add, I'd have to add another parameter here. I can't just somehow tell Java, get the y from somewhere else. I can't just out here say what y is. Well, actually, I can in a funny way. Let me show you. There is something I can do the following. Static int y equals 69. Well, let's see. We'll make it, I'll make it a big number so you can see it real easy. Okay.
You misspelled
Yeah.
static.
And I should say, the way we usually say it's public. So you notice how we call this public static? Then I do a public static here, int y. That actually is the equivalent in Java of how you say that m is 5, m is 3, b is 5. Now here's the function. The function uses, the x comes from the function call, but the m comes from over here. Okay. Now I can go, now watch, this will work now. This y actually is that y there, but it'll never change now. Notice that there's this new box up here that just tells us that y is 1001. Actually, that's 10,001. This box up here tells us what y is. Okay. Then see down here when I print, see I got that y equals. Okay. So I actually can do in Java the kind of thing you're doing in math here. There is a way to say that there's these extra variables, but they're constants. See, they don't change every time. Just like in here, this is the slope constant, and this is the y-intercept constant. Okay, every time you call the function, you use the same constant, unless you change the constant. Unless you go in and do, but it isn't the function that changes the constant. Something else would change the constant, and then this would call the function now with the new slope. Okay, so right now y is 10,001. You know, it's one last thing. You know how it's hard to read that? Is it 1,000, 10,000? You can't put a comma in there. Java doesn't let you put commas in big numbers. So like if you have a number like 1 million, 1 million is 1 with 1, 2, 3, 4, 5, 6 zeros. But that's really hard to read. And you're not allowed to put commas. But there's a weird thing that they let you do. Instead of the commas, you can put underscores. Bizarre, but it's got to do with weird facts about the way the language works. The comma's just too confusing to Java because the comma's used in so many other ways. See how the comma's used here and here. So Java decided that when you have large numbers and you want to separate out where you would put commas, you put underscores. Okay. See how that works. So that's now the number 1 million. Notice over here, it's not shown with the underscores. So it's hard to read here. How many zeros are there? Well, you have to kind of count them. So unfortunately, you'd think that programming languages would be real sophisticated, but in a lot of ways, they're really stupid. There's just a lot of dumb things that make it hard to be a programmer, like numbers, big numbers without commas in them. Why in the world would they let you put underscores over here, but then they don't use them over here? And it can become really hard to read these numbers. Okay, so now this y acts just like the constants here in a formula like that. Okay, well, we've actually run out of time, so we'll quit there. But what we've talked about are method. If you think about it from the math point of view, we've talked about defining methods and calling methods. And we've talked about constants in a method also. So we have defining methods, calling a method with arguments and also without arguments. And if I want, I can put a constant in my method. So I can put a constant that gets used inside of the method. Okay. All right. So we've run out of time. And anybody got a last second question? Anybody got a question before we leave? I'll put these examples up on the course website. You know, we've done several iterations of this example. I'll put them up on the course website. So there'll be links to them. So you can go back and play around with these examples. So I'll put links to these examples. That's one reason why I saved them. So I'll put links to them so you can play around with them. Make sure you read this chapter 4 because it introduces a lot of ideas. We're talking about a lot of ideas here. So read chapter 4, and then these sections reintroduce those ideas again. See, there's methods with parameters, you know, without parameters and with parameters, methods without parameters, and methods with parameters. Okay, we've got methods without and with parameters. So here they've got. So there's a section about methods without parameters and methods with parameters. And also, hopefully later today, there'll be your next program assignment up there. So I'll try to get that up later today. Okay, any last question? Any last minute question? Okay, so again, we covered a lot of ideas today, and they're real important ideas. This method stuff is not going away. It's one of those ideas that it's not like we did it for a while and then we're going to go on to something else. Methods are the heart of computer programming. Methods are what programmers do all day, every day. We write methods. So this is the key, maybe the key idea in the whole course. Okay, so I'm going to stop here and we'll meet again on Thursday and have office hours this afternoon. You know, later this afternoon. And if you have any questions about things, you can always send me email or come to office hours. Okay, so I'll stop here and say goodbye. See you again on Thursday. Bye.